So we have a few posted images that look great from between webinar 1 and now. This is a Whirlpool Galaxy from Annette, who's at one of our Smithsonian affiliate museums in Ohio. And I noted that Annette wrote down, "I've learned that I really need to keep notes on what I do." And I was just finding that today as I was using JS9. I wanted to keep track of how I got a particular effect. And I wanted to point out to you that in the educator portal, we have an observation sheet that's great for keeping notes, and that's good for your students too. It's in the useful resources section, and it's in this section you'll see there's a few different things that can be useful. The Alien Eyes activity, we're doing a portion of that during today's webinar, so that write-up is in useful resources. It comes to us from the Astronomical Society of the Pacific. But there's this telescope observation log sheet, and let me just open that. The telescope observation log sheet, there it is. This is really good for students to keep track. Obviously, in the Youth Astronet portal, their green image archive page does keep track of the objects they've asked for and the date they were taken and things like the exposure time and filter. But after those images come back and students work on them and process them, this notes column is really good for keeping track of what color palette they might have used, what the high and low brightness settings were, to get that effect. And so I wanted to point out that tool on the educator page in the useful resources section. Let's see, as we go through others' images in the request and process here. I noted that Sandy posted an image of the asteroid Iris and used a fire color. And one thing, this image looked to me like it might have been cloudy, because usually images, the asteroid looks just like a star and it's basically in a field of stars, and I don't see many stars in this image. So I'm going to show you today, when we open up some images in JS9, techniques for finding out if you're not getting anything out of your image because you just need to work a little harder, or if it might be because it was actually cloudy and there's nothing in your image. And there's also a video tutorial about how to see if your image is cloudy. There's some other people who posted their images using different color palettes. And these, of course, are all false color. In other words, we use the JS9, the JS9 interface here to give an image different colors, assign different colors to the, I'm going to open a Orion Nebula here, if I can find it somewhere. There we are. So we assign different colors to the different brightness values. So right here, this is telling us anything above 3704 is going to be orange or yellow. And in fact, we see that in this image, that only includes this little star here. That's it. If you look right here, 4095 or 3000, and this star here, if I get right in the middle of it, is 4095. So those are the only things that appear orange or red. But this whole nebula that's colored green is way down here in the 600, 700, 800, 900. So this is very dim. Now, last webinar, we talked about the fact that images are numbers, astronomical images, digital images are really just a file with numbers laid out in X and Y, and each of those XY pixels has a brightness value, which in telescope detectors tells you real information, scientific information about how much light came from that place in the sky. And so today we're going to need a particular tool of the image processing that I just wanted to go over one more time. I think I might have gone over it in webinar 1, but we're going to need to use this log scaling feature. So I wanted to go over that quickly before we get to using color filters. So here's, when I first open up the image of this Orion Nebula, it looks like there's nothing there. And we learned how to kind of bring down the high brightness value. So now dimmer things are going to be colored white. Here they come out, so dimmer and dimmer things. So again, we get those light shades of gray and white for the very dim nebula. But if the one thing about using the log scaling is that it really enhances the very dimmest parts of objects in space. And often those objects are barely brighter than the background sky. And so it's very hard to visualize them. So let me show you an example of that. I'll click on log here for this Orion Nebula image, log. Now, that doesn't seem to make it much better, because in addition to enhancing the dim parts of the nebula, I've enhanced the dim background sky here, which as I move my cursor around, you'll see that it's about 440. If you can look right down here in the pixel value as I move my cursor around. And so, you know, this log scaling is giving values of 440 of a very light gray color, so there's not much contrast. So there's two steps to really bring out a dim image. One is to click on log scaling, but the second is to set the low brightness limit to the value that you find by moving your cursor in the background sky. And can anyone type in the chat box what I should set my low brightness level to? I'm kind of moving my cursor around. Any suggestions in the chat box? So I want to set it to the pixel value of the background sky. All right, so, Carrie has suggested 430. Well, let's try it. And again, as I go around, we see values of 435, 440. So let's try 430. And I'm going to hit enter and watch that image of the Orion Nebula when I hit enter. Oops, there. Popped right out from the background. And Carrie, if I go even just a little higher, one step at a time, you can see we can really, that Orion Nebula really pops out. So that's the technique we're going to use to bring dim features out when we're doing 3-color imaging, which I'm going to show you how to do next. Are there any questions about those these controls? One thing that our programmer Aladdin keeps bringing new updates from the scientific side of this image processing tool. The astronomers who are using it have developed some new features, and Aladdin has installed them for us. And one of them I want to kind of warn you about because it can happen accidentally. We recently added these stretch and contrast tools, which in webinar 1 I explained if we set to this rainbow palette that only has a few colors, that either stretch the colors over more values or squeeze them over fewer, or shift them to dimmer values. So see that you're starting to see more here, or shift them to brighter values. In addition to these bars, it turns out that if you click and hold your mouse on the screen, when you go up and down, you do that stretch contrast change. And when you go left and right, you do the shifting. You change the shifting. And so when I stop going left and right, you see that the value of those changes. Now, that's once you really gain some expertise in what you're doing with an image, that can be helpful to get to a visualization that you like. But sometimes I find it works a little too fast for me, so I like using the one at a time controls better. So I just wanted to note to you that there's now several ways to change the appearance of your image. There's the traditional low and high brightness limits that set the brightest color in the color palette and the dimmest color in the color palette to set the value. There's these stretch and shift things that shift the color palette over different values or stretch. And then there's actually touching the image with your cursor, or if you're on an iPad with your finger, and that will change the image as well. All right, let's go back to our, actually I think I'm gonna just stop there and reload so we have a fresh thing without an image in it. All right. So the next thing we are going to do is take 3 different images of an object that were taken through 3 different physical filters in the telescope and use the computer to actually add those images together to create what's called a true or representative color image. In other words, an image that actually represents more like what the object in space would look like if you had giant eyes and could collect photons over 60 seconds. You would actually see colors. When you take those images, they look, again, black and white. The detector doesn't know the difference between a blue photon and a green photon and a red photon. It just knows in these 3, you can see more light seems to have come through the red filter, unless this one's the blue, right? More, and so in the next step, we tell the computer, this is the red, this is the blue, this is the green. And then by adding those images together, we're going to be able to create true color images that look more like what the Orion Nebula actually looks like. It's kind of this very pinkish gas, hydrogen gas that glows pink. Before we do that with real images, I want to do an activity with you. And for this activity, I'm going to actually stop sharing my slideshow. And what I want you to do is find the video of me on your screen and click on it, and there'll be a little menu button that'll pop up and say pin video. So you want to pin the video of me so that it's large on your screen and you're seeing my nice messy office, and you're seeing that I'm wearing this somewhat Christmassy outfit here of a green sweater and a red shirt, and that will become apparent in a minute why I'm wearing these bold colors. So we're going to do a little predicting using the chat box, and here's what we're going to do. I'm holding up right now a little piece of cardboard that has 5 stars, 5 construction paper stars on them, and these stars are star-shaped, since actually stars are round, not pointy. So imagine I have these 5 stars, and we have green, white, blue, yellow, and red. I'm going to use some filters, some colored filters, and and put them in front of the webcam that you're looking at me on. So, I want you to predict. I'm going to take a red filter, and I'm going to put it in front of the webcam. And so I want your prediction of what's going to happen to these 5 stars. Are they all going to turn red? Will one circle disappear or another disappear? Which ones will seem brighter? What will happen? And so I want you to make some predictions in the chat box. And if you're nervous, you kind of don't want to put yourself out there. You can make those predictions to me privately. Just click on my name and make your prediction, and I won't say who's saying it. But I hope you'll be willing to take a risk. We want everybody to take a risk and make a prediction about what you think will happen when we put a red filter. And this is a tough thing to figure out, so don't worry. We don't care if you're right or wrong. We just want you to kind of try to make a prediction. So I'm waiting to put the filter over until I see some predictions coming through on the chat box. What will happen when the red filter goes over? Will number 5 disappear? Will they all turn red? Oh, you guys are so shy. I know you can do this. You can type to me or to Erica privately. All right. I'm not going to do it until somebody makes a prediction. Okay. So thank you, Carrie. Thank you, Jessica. This is great, and I really appreciate your taking a risk. So Jessica suggests that 5 might disappear when we put the red filter up there, and Carrie says number 1 and 4 should not appear. So you're saying that those will disappear. So we have 2 different predictions here. And then 3 might look purple with the red over it. And 2 look light red. And 5 would disappear. So, okay, yeah, good. All right, so we have some suggestions that 5 will disappear. There might be some changes in colors of things, okay? Let's check it out. Here goes the 5. Okay. Well, 5 definitely didn't disappear. This is a little strange because I know that you're thinking, well, let's see, it's a red filter. Maybe it filters out the red, so the red should disappear. And here's where it's important to think about what a red filter does. So the red filter between me and you on the camera, it only lets red light through. It's a red passing filter. So any place where there's red light traveling to that camera, you'll see that thing. That thing will appear bright. And so the red star, the red dot, number 5, is red construction paper reflects red light. That red light is going to the camera. It gets through the filter because the filter lets red light through. And so 5 appears bright to you. But the green, number 1, that green star, green construction paper and green stars, don't emit any red light. It's reflecting only the green light. The green light gets to that filter, and the filter doesn't let green light through. It only lets red light through. So this appears dark. And the same is sort of true, although there's this blue construction paper might have a little bit of red in it that's getting through that filter. The white star definitely reflects a lot of red light. It reflects all colors of light, like Erica's sweater, for example, is a white sweater. It's reflecting all colors, and so her sweater looks white, and so does the white. It looks bright through the red filter, and it looks red because only red's coming through. And the yellow construction paper also lets light through. Okay, great. So now I want you to make the next prediction, which I think you'll be much better at, which is if I put a green filter over the camera, will any of these disappear? And what will happen to the green dot, and what will happen to the number 5? In fact, you can just talk about those two. I'm going to put a green filter that only lets green light through over the webcam. Any predictions about what's going to happen? Now, so when we put the red filter over the camera, okay, so thank you, Carrie. Suggests that number 1 will be bright this time, and number 5 and number 3 should not show up. John suggests the red will disappear, and the rest will show. Okay, let's check it out. So there's the red, and now to the green. Excellent. So, right, so the red did disappear because there's no green light getting to you. The red star is not reflecting any green light, and so no green light is getting to you, but there's green light being reflected from the white star. There is a little green light gets reflected from this yellow piece of construction paper. Green light gets reflected from the green construction paper, and there's a little green light from 3 as well. So as John suggested, all of these you see a little bit, maybe less well than before, but there is some light getting through there. If we look at my sweater combination, I don't know if you'll see that my sweater's looking bright through this filter, and my shirt is looking dark. And here, my sweater's looking dark and my shirt is looking bright. So does anybody remember from when we started what color shirt and sweater I actually have on? Put that in. One of the reasons I'm asking you to make predictions, and that I suggest when you do this kind of activity, yeah, red shirt and green sweater, exactly. Right. So one of the reasons I ask you to make predictions and kind of wait until you make those predictions and suggest that you do it with students as well, is that light and color is a very difficult concept. You have to think hard about it, and the research shows that if you make a prediction based on your thinking, and I can guarantee all your students will have the same kind of thinking, students and adults. When you say, I'm going to put a red filter over something, they'll say, oh, the red should disappear. It makes sense when you first think about it. But when you make a prediction and realize, oh, something's different than what I thought, the learning sticks much better after making a prediction. So that's one of the reasons why I kind of make you put yourself out there in the chat box. So, all right. Well, now that you've kind of figured out how the filters work, and by the way, I'll put a blue filter over, which is sort of interesting. On the blue filter, the blue construction paper is sending blue light through. The white construction paper is sending some blue light. In this case, the blue filter is not a perfect blue filter, and so a little bit of green light gets through that filter, and the yellow is not reflecting much blue light, so that's pretty dark, and the red is not reflecting blue light. So now that you know a bit about these filters, I'm actually going to go the other way now, and this is where the alien eyes activity comes in. I've given you all alien eyes that only see in red, so you're looking at the planet Mary's office, and in Mary's office there are some trees, and I want you to figure out which of these trees, 1, 2, 3, or 4, might be green like trees on Earth. Okay, you can't, of course, your alien eyes can only see red. You can't see this strange color green. So, but you might have some hypotheses about which of these trees might be green right now. Any guesses about which tree might be green? We have a number of guesses. We have 1, 2, 4, and 2. Okay. So we have a couple of guesses for 4, a couple of guesses for 2, and 1 for 1. Let's see if another filter will help you narrow it down. What if I put the green filter over the camera? So I'm going to put the green filter, only letting green light through. So a green tree is reflecting green light. You should be able to see it. A red tree is not reflecting green light. You shouldn't be able to see it now. So are there any further? Okay, so John thinks 2, 3, or 4 could potentially be green. All right, 2, 3, or 4. What if, what's going to help distinguish which one is likely to be the green one? How's that? Red. Yeah, you're right, 2, 3, or 4, red. Let's put the blue over. And blue. So the blue filter lets through tree number 2, but not so much tree number 4, and it lets through tree number 3. So Jim is changing to 4, all right? From 2. Let's check it out. All right. So you definitely were able to reason that 4, because it disappeared with the red filter and came through with both the blue and green, had a possibility. These, of course, would be a little confusing because a white tree comes through every filter. And the blue one is a little tough because that green filter lets in a little blue, and the blue filter lets in a little blue, so that's a little tough. But great job. Now, when we put filters over the telescope detector, the same thing happens. If we take an image of a nebula, and it's glowing with all the colors, when we put the red filter over the detector, only the red gets through to make an image of only the places where red came from that nebula. And likewise for the green and the blue. And so I'm going to bring up, oh, I'm not, you're looking at me, aren't you? You aren't looking, thank you. All right, well, I need to share my screen with you. I'm looking at something that you aren't. There we go. There we go. Yeah. So this is the filter wheel that's actually inside the camera, inside the telescope. And again, when you take a picture through each of these filters, only that light gets through the filter to the detector. So let's take a look at an image I took a couple weeks ago. So we're going to go to JS9 and I'll show you how to make a 3-color image. So in my list, I have actually these Trifid Nebula, which is one of my favorites. Came out pretty well. I think the ones I took more recently actually is cloudy. And I can actually show you that. Let me take a look here. Oh, not so cloudy. I think it's cloudy for only one exposure. Well, let's just go to the image I want to use. Let me close that. So I'm going to go to these Trifid Nebula images. I'm going to first open the blue one. Okay. And again, when I first open it, I don't see much, so I want to hit that log scaling. I still don't see much because the Trifid Nebula is very dim. It's barely above the background sky. So what do I want to set the low brightness limit to see if I can see this Trifid Nebula? Something like 297. If you look right here, when I move my cursor over just the background night sky, it's around 290, so on. So let's do 290. 290. Watch this region. Whoops, I went 290. And something starts to come out there, but it's still very dim. I don't even know if you can see it on your screen. So I'm going to bring this high brightness limit down to make dimmer and dimmer pixel values appear light gray or white. And so there it starts to come out. There I have it. So that is the Trifid Nebula. It's got these 2 blobs, and it's called Trifid because it has this like these 3 dust lanes that go through the nebula. Okay. You'll notice that just that one change from 290 to 291, 290, 291 gives a little more contrast. And now I'm going to open up, and I'm going to, actually, so that's the blue image. I'm going to tell the computer that it's blue. So we'll colorize it blue. Now I'll go open up my green Trifid Nebula. Okay, there it is. Again, there's not much there, so I'll hit the log scaling button. Still don't see much, so I'm going to set the background sky this time to like 295. Yeah, good. I think I heard Adrian saying, oh, it should be 295. All right, and still a little dim, but let's bring down that brightness value, and there it starts to come out. Okay, so that. Now, let's say I've forgotten what color filter this image was that I just opened up. There is a way for you to tell in an astronomical image, because these images, when they first open up in JS9, they're a format that you've seen written in the file name called FITS, FITS format. That turns out to be a very special image format that astronomers use, and the reason astronomers like it is because the data from the telescope includes not only the brightness values for every pixel position, but it also includes all kinds of information about how that image was taken. And you can look at that information right here under Image, Display Fits Header. And when I look at that, you get all this information, which can, it looks a little confusing at first, but if you look down through, it has the file name, it has the date the observation was taken. This is May 2nd. It has the object, the Trifid Nebula, also known as M20. It has the coordinates in the sky. That's what right ascension and declination are. It's kind of like longitude and latitude in the sky. But here, it tells you right here, it's the green filter. So you can always find out what filter. And here is also where you can find out whether the weather was decent when the image was taken, if you're not seeing anything. And that's right here. This weather value will be a number from 1 to 100. And so if you're not getting anything in your image and you open up the FITS header and it says weather equals 20, or weather equals 50, or weather equals 0, it was probably pretty cloudy that night. And so you might not have much in your image. But you see that our Trifid Nebula, the weather was 99, so that's pretty good. All right, FITS header. We just found out it was green. I'm going to color that green. Okay. And you notice that this particular image, you see how all my stars, rather than dots, they look like lines. And this is one of the things that happens because we're using a real instrument. This is not, perfect textbook images. The wind was likely blowing or something like that when the image was taken, and so the telescope moved a little bit back and forth while the image was being exposed for those 60 seconds, and that's why you get this little horizontal dot rather than a nice round dot. Let's go open the red image. Again, we need to hit log. Then we need to set the low brightness value to about 290. There we go. We start to see it. But if we bring this high brightness value down, then we see more. And it looks like I could actually go up with my low brightness value to get more contrast between that background and foreground. So let's try that. 291, 2, 293, 4, 295, 6, 7. I like that better. Right, so I get a nice contrast between my, and I think I even, and some of the others brought this down lower. So I do that the same for all three. I'll color this one red. And so now you see I have 3 images. That's my red. This is my green. And this is the blue. And they're all roughly the same low and high brightness setting. They all have the nice same contrast. But now I need to add them together. So these are 3 separate images. One, only the blue light from the Trifid Nebula came in, one only the red, and one only the green. So what I need to do, I'm going to actually set it to the red image so you can see what happens here, is tell the software I want to go into RGB mode. And what that does is now all 3 images that are kind of hidden in 3 layers here will all be added together. So you'll see all 3 at once. So it's adding the numbers of the pixel values for the red, blue, and green all together. And we'll click that. And suddenly you start to see some color to this nebula, but they aren't aligned quite perfectly. The telescope wasn't pointing exactly in the same place, so we want to be able to shift these images with respect to each other. There happens to be a tool for that. It's called Shift. All right, I'll put that right here. And so I don't know if you could focus your eyes on right here. You see where it seems there's a green dot, kind of a red right there, and blue right there. So they aren't kind of. So I'm going to shift the red up first. You see it gets further away. And now I'm going to go down, and what I'm trying to do is align it right with the green. That looks pretty good. Now I have this blue dots that are above my red-green, which added together makes yellow here. I'm going to shift that blue, whoops, no, sorry, you see what I just did? I'm still on the red image, as you can see from the color bar. So the shift tool only works on the red image. I need to go choose my blue image and now use the shift tool for that. Shift, shift, down, 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 and maybe a little bit to the left. There we go. So now I start to see the real colors of the Trifid Nebula, and I can do a little fine tuning if I want by, oh, too much fine tuning. Let me try that. Oh, what just happened to my blue? I lost it. Let me go to my red. Let's go back to RGB mode. There we are. Okay. So, I don't know what happened to my blue. I think I might have done that thing where I move my cursor on the screen, because my blue I definitely don't have much blue in here. But you can see in this image that the Trifid Nebula, the thing I really like about it is that the bottom part of the nebula is kind of pinkish and the top is kind of bluish. And it turns out that that's really the case out in space. This nebula is made of lots of hydrogen that's glowing, and hydrogen glows pink. And this area is like interstellar dust and stuff that scatters light just like our blue sky does. And it's scattering the light so that more blue light is coming towards us. And so we get kind of blue up here and pink down here. So I have that nice image now, and I want to I'm gonna tweak it a little bit here. Oh, oh, I lost my red now. Here comes my red. You can see a little tweaking. There we go. There it is. Nice red and blue. So I'm going to save that as a PNG and call it Trifid Nebula. All right. And there it is, my true color image that I am now going to show you a new way to post it on the portal. And this is to create your own web page, what's called a Wiki web page. And this is a great tool for working with students. So that's why we want you to practice posting to the Wiki. So I'm going to go back to the educator portal. And instead of posting my Trifid Nebula in the request and process an image, I'm going to post it, in this wiki, and this little thing that looks like a fabric is the Wiki tool. And when we click on that, you'll see there's some instructions at the top. I'm going to go through how to do it now, but you can read those instructions. And there's also a video tutorial on creating a Wiki page, so you'll be able to watch that too. You'll see that on this page we have all the teachers from January who created their Wiki pages. And then we have Sarah's the only one who started with a Wiki page, and I've done a couple. So you're going to create the link to your page down here in the May cohort, and I'll do it again so you can see how to do it. You click on Edit, and that's editing this table of contents page, which links to all the individual educator pages. So I clicked Edit, And what I need to do is go down to the bottom where it says May Cohort. And I'm going to add a new page to show you how to do that. And to add a new link on the table of contents page, you always put, if you want to make a link, you just name it and put brackets around it, double brackets. So here's bracket, bracket. This is Mary's third wiki page for RGB, bracket, bracket. I'll save that. And now if I look down, there it is. It's red because I haven't added any content yet. So you click on it to add your content, and it says new page title, Mary's third wiki page for RGB. I'm going to click that, create the page. So now you create the page in the same way that you would use this editing text box for one of the forums. So I'm going to, here is an RGB image of the Trifid Nebula. And then I want to add an image. And I'm going to show you a way to put text next to an image rather than underneath it. And one way I do it is to insert a table so that the left column is going to be the image and the right column is going to be the text. And I'll make the width of that table, I don't know, 800 pixels, even something like that. And there it is. So in this, this is where I'm going to upload my picture. I put my cursor in that little box and I press the picture icon. And remember, I downloaded that PNG file, so I'm going to go find it. Choose file, and there it is, Trifid Nebula. Okay, I'll upload that file to the overwrite. So here it is in the image in my text. I'm going to give it a image description for screen readers. Image, color image of the Trifid Nebula. Right, and insert that. And it's a little bit big here, so I'm going to try and shrink it a little bit. And to do that, I just click on it and drag the corner up here. And that's pretty easy, so that looks better. So there's my image, and this has this odd, this table maker has this odd thing where my second column has gone, it's over here. So I can, just like you're in Excel, if I hit the tab button, I think I'll be in the next column. And I'm going to type a little caption here. I like how the bottom part of the nebula is pink and the top is blue. Okay, and I want to make that text nice and big, and I want to color it red, and then I'm going to save that. So there's my page, and if I go back to the Share Your Processed Images page, there I am at the bottom. My link is now blue because it has content in it. I click on it, and I've created a web page. And with your students, this is how they can create a web page that might contain research they've done on their image, or their capstone project, lots more information. You can continue to add to this page when you want to add more to it by editing it. Any questions?
Mary.
Yeah.
Mary, can they add the text within the image if they choose to, instead of outside of it, instead of creating a separate column to write a text?
Yes, although that's there's really two ways to do that, and I didn't do it here. One way, of course, is in JS9. When I was in JS9, which let's see here, right? I could have made a text region,
Right. Okay.
and done that. Trifid Nebula, right? And apply that. And close it. There it is. Right? And I could add more text too. One trick I like to do is create arrows by using the caret signs that are above the comma and periods. So like that, and then a bunch of hyphens. Right? So that's an arrow. Hit apply. And now I've got a nice arrow. I can even do that. Like that. There. So I could have saved that as my PNG file. To answer your question, Adrian, and then uploaded that so my text would be over it.
Okay. I just wanted to, and when it came to the wiki, if they could have a choice.
Yeah. Yeah, so they could do this. Within the wiki does not have a photo editor, so you can't add things to the image within the wiki page, right? There's no way for me to now add text over this, I don't think. Yeah, but you can do it before uploading the image.
Okay.
Yeah, and of course you can use any photo editor too. To do that. I happen to be on a Mac, and you see I've opened in preview my image here, and preview happens to have this annotate function, and I can draw ovals, you know, like that, and I can add text. I think annotate text. This is my nebula, right? So you could do all that and then resave it and then upload that modified. So that's post-processing.
Oh, okay.
So you can do that too. Any questions from anyone else on that? That's a good, thanks Adrian for asking about that, because students definitely want to make that image theirs. I definitely want to make that image theirs. Now, one thing is sometimes students don't know what to write about an image, and so the last activity for today's webinar is I want to do an interactive activity with you all. You're going to need to use your text box again. And it's an activity called Astro Poetry. And this is an activity that we used to do. I learned it from a museum educator I know. It was called museum poetry. But it's a great activity. If I were in a classroom, I would have 3 or 5 index cards or Post-its for each student. But we're going to use the annotate feature of the Zoom webinar for this. And what we're going to do is we're going to look at an image. Now, I've chosen an image that is not from Micro Observatory. This is a NASA Hubble Space Telescope image of the Orion Nebula. Although if you remember, the Orion Nebula I showed you from Micro Observatory, which I encourage you to try and make a 3-color Orion Nebula. Remember, see, there's one from Micro Observatory on the right, and here's the Hubble. So it's the same colors. Again, the way professional astronomers made this image is exactly the same way that students do. The Hubble telescope has a filter wheel. They use green, red, and blue filters. The Hubble happens to have a lot more filters. And they combine them in image processing to create a true color image. The Hubble telescope can't see color either. You have to use a computer to add filtered images together. So here we have this great image. It's beautiful. And what we're going to do to create a poem for it is I'm going to write some text. I'll make it yellow so it shows up on the screen. And I want you to suggest descriptive words. And I see that Adrian has already typed in some descriptive words. Well, and so if people want to just do kind of a single word at a time, try and come up with verbs, adjectives, nouns that describe what you see on the screen right now. So just type a single word in the chat box and we'll add it here, right on here. I'll start if people, oh, excellent. Purple, great, powerful. Oh, nice. Wisps.
Poseidon.
Oh, Poseidon. Oh, is that EI? I better look. Yeah, all right. Those are great. And the others I see abstract. Nice. I see swirling going on. Any verbs here? We need some verbs. Erica says flowing. And I think there's something glowing. We have an explosion going on. Okay. Growing. Nice. Oh, Erica's calling from the back. Cotton candy. And Carrie has said free flowing. Nice. Free flowing. All right. Have any other words here? Colorful. Nice. Yes, definitely. So yeah, don't forget to be quite obvious when you look at it. So some of these descriptive words are just kind of exactly what you see, and some are something you might know about the object. Oh my goodness, these are great. All right, whoa, whoa, inviting. And dancing sky. All right, let's hold it there. We've got a lot of words. Now, if I had students who have all these index cards with these things, the next thing is that students would actually move the index cards to create lines of their poem. And so I can do the same thing here using the select tool. I can move these around. So if anyone would like to type in the chat box some first initial line made out of some of these words. So do we want colorful swirling explosion? Let's try it out. Colorful, where did that colorful go? I lost it. Colorful, swirling, 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 swirling. Colorful, swirling, explosion. Next line, anyone? You can put Adrian's A Beautiful Swan. Wisps of cotton candy. Ooh, I like it. Wisps, I'll just add of quickly. Cotton candy. Nice. Do we have any? Oh, I think we have some alliteration here. It looks to me like there might be a powerful purple Poseidon. Let's try that. Purple, powerful purple Poseidon. Whoops, wrong one. Poseidon. Okay. Oh, I see, John. John wanted Poseidon's powerful wisps. Well, see, now we have more versions of the poem than we can, and actually we've had students do this where it's different groups of students take the same words and they create different poems. We'll keep going here. Let's see if we can finish off using the words we have here. Growing, glowing nursery. In a dancing sky. Oh, nice. I like that. Nice. We might need to add something here, or you know what? We could just take all these out and kind of end it there. And no one says we have to use all the words. So we've made a poem now. Colorful swirling explosion, a beautiful swan, wisps of cotton candy, powerful purple Poseidon, glowing nursery in a dancing sky. I feel like a beat poem here. This was a thank you for the poetry slam. We've already had some students in the actually let's do a screenshot of that so we can see what you guys created. Okay. Let's see. Okay, I'm gonna clear the writing here. Stop that to be in here. Exit. And we've had some students already posting pictures with poems, which are very nice. And sometimes that's a nice way to have students both make careful observations of an image because they are being descriptive of exactly what they see. And it also frees them up to kind of interpret the image. So that's one way of creating a capstone project. We have some students who've posted images along with their, in fact, I'll show you one here. Let's see. Here we are in the youth portal, and under the astrophotography forum, we have a group here called Cool Star, and each of you, when you sign up a group of students, will give you a group name. And so you'll be able to create a discussion line that only your group will be able to reply to. And here in Chelsea Dorman's group, she asked them to post their image with a caption that's either an astro poem or tells us what you think about the image, and a label. And I'm gonna kind of go down. You'll see there's lots of images kids posted, and way down near the bottom there's a couple nice poems here. Let's see, where are they? Here's one. Large star in the center, gazillion small stars surround, red stars all around. Is that a haiku? Dun, 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 dun. No. Anyway. And another student had the same image with a different poem. Distance of galaxy, light years away. Star probably disappeared thousands of years before today, but here in this image, forever to stay. And then they talked about they like this image because it looks like there's a new star forming. This image is actually a whole galaxy forming, but that's a pretty nice interpretation. All right. So your mission is to take your own RGB image, create your own wiki page, and by the end of this online workshop period, your capstone will be to create a separate wiki page with information about what you'd like to do for your implementation. And so that will be your capstone for the online training. I wanted to show you some examples of youth capstone. Adrian, you might remember these young people from the Vine Street who took images of nebula, and then they also had Hubble images of those same nebula. They had micro-observatory and Hubble images, and then they made sculptures of those nebula. So this crab nebula, these girls made a nice crab nebula sculpture, and these boys are making a ring nebula sculpture, as I recall, and creating an exhibit. That was their capstone project. As I said, your capstone for the online workshop will be to respond to the prompts on the Educator Capstone Project Wiki. And let me just go there quickly so you can see an example. Here, okay. Your capstone project, we're in the Educator Capstone Projects. And again, you can see this is the May cohort. I'm sorry, January cohort. And let's take a look at Stephen's capstone project. So after using all the materials and trying things out, he says he has a personal interest in digital design and manipulation. So the RGB True Color assignment was really cool. And he began to imagine what could be a great capstone project for his youth. This would be a great opportunity to incorporate their maker lab. And he's thinking about, I think he's actually just starting right now with kids doing it, having the participating youth create objects in the maker lab that have been inspired by their astro photos, and then a short video explaining the connection. And then these three things would all become kind of a public performance. So again, the thing about the Youth Astronet tools is it's very adaptable. We have these essential elements, which are, we want your young people to learn how to use our telescopes and the image processing, and we want them to learn a little astronomy or about light and color or do some interpretation, and then pursue some kind of project using their images that's of interest to you and to them. So those are the essential elements, but really you can do it in many different ways. And so we encourage you to explore during this next week all of the materials online, explore the Youth Astronet portal, take a look at what you see others have done, and ask us questions. Next week, on Wednesday, Thursday, and Friday, Erica will be hosting live office hours. And basically, if you look over here in upcoming events, if you click on any of these on Wednesday, if you decide, you can see she'll be available online from 10:30 to 1. So anytime in there, you're trying to use the RGB and you can't get it, you can't figure out why, just click on that link. She'll be on the other end, and you can even share your screen with her and troubleshoot any problems you're having. So, so we have office hours with Erica next Wednesday, Thursday, and Friday. And here's, so Thursday, She's got herself available from 10:30 to 3:30 online. That's great, and a little bit on Friday too. So, click the arrow right above the event. Friday. Ah, there you go. Yeah. So Friday, 10:30 to 1:30. The week after, we'll be having some wrap-up webinars where we show you some additional activities that are available to you as Youth Astronet educators. One of those activities is an activity about, I don't know if you can see this in the, here's egg cartons and there's little beans in them that represent photons. It's an activity called From Pixel to Picture. And it's an activity for kids to model what's happening with the detector of the telescope. Another activity we'll demonstrate during those webinars is little bit circuits, which we have kits, workshop sets for up to 30 kids of electronic bits and engineering design challenges, which you'll see on the educator portal, so that kids can kind of do the engineering design process that goes into the robotic telescope system they're actually using. Some of those design challenges are design a mechanism that can point a telescope anywhere left or right or up or down. And I'm actually going to turn this one on and show you this, these bits. I don't know if you could see. I'll try and get close here. If I slide this slider, right, I'm pointing, there's a light sensor on this slider and I'm pointing it straight up or over to the side. And then there's this part here where I can point it all around. So these engineering design challenges are something we can demonstrate in the wrap-up webinars too. Those will be recorded and we'll, do we have those already on the calendar? We don't have them on. We'll put those on the calendar as well and send you an email about them. So I'm going to unmute everyone in case anyone has a question. And it's easier to ask than type in the chat box. Before we go. All right. Well,